In this notebook, we will do some exploratory data analysis over our dataset. However, since we don't have our features created yet, we cannot do much at this point. In addition, when we create them, we won't be able to extract many insights because of the nature of text-based features. For this reason, only a shallow analysis will be done at this point. It is a common practice to carry out an exploratory data analysis in order to gain some insights from the data. However, up to this point, we don't have any features that define our data. We will see how to create features from text in the next section. But because of the way these features are constructed, we would not expect any valuable insights from analyzing them. One of our main concerns when developing a classification model is whether the different classes are balanced. This means that the dataset contains an approximately equal proportion of each class. For example, if we had two classes and 95% of the observations belong to one of them, a dumb classifier which always output the majority class would have 95% accuracy, although it would fail all the predictions of the minority class. There are several ways of dealing with imbalanced dataset. One first approach is to undersample the majority class and oversample the minority one so as to obtain a more balanced dataset. Other approach can be using other error metrics beyond accuracy, such as the precision, the recall, or the F1 score. We will talk about these metrics later on. In our notebook, we first import the pandas library, the library, the pickle library, the seaborn library, and the alter library, which will be used for the creation of graphs, and the warnings library to indicate warnings during the classification of the text. We have filtered the warnings to ignore so that unnecessary warnings do not arise. We then load the dataset. A section of the dataset can be observed as follows: the file name followed by the content, followed by the category, and the complete file name. The file name is a numeric value of the number of text in .txt format. Then we have the content, which is what the file contains. Then we have the category, which suggests which topic the content might relate to, and the complete file name is composed of the file name followed by the category. We then see the number of articles present in each of these 5 categories and create a graph for the same. We can see that the classes are approximately balanced, so we won't perform any undersampling or oversampling methods. However, we will anyways use precision and recall to evaluate model performance. From the graph, it can be observed that the business category has 510 articles, the entertainment category has 386 articles, politics has 417, sports has 511, and technology has 401. The percentage of articles in each category can be found using the pandas library and categorizing them into data frames and then creating bar charts for them. Now from this creation of bar charts, we can see that 22.9% of the articles belong to business, 17.3% of the articles belong to entertainment, 18.7% of the articles belong to the politics, 23% of the articles belong to sports, and 18% of the articles belong to technology. These classes are approximately balanced. For any classification, we train the models without oversampling or undersampling, as in how we have done in this case. If some kind of a bias is seen in the model, we use the techniques of oversampling and undersampling. And since there was not much of a bias in our model, we did not have to use either the oversampling or the undersampling methods. News length by category. Definition of news length field. Although there are special characters in the text, it will be used as an approximation. We create the news length. We create a histogram for the news length and news length distribution, where our count value is 2225, mean being 2274, standard deviation is 1370.78, and so on, and so on. The other fields such as 25%, 50%, 75%, and max are found. The news length distribution is as graph suggests. We can get the number of news articles with more than 10,000 characters. Let us see one such news article. We have a long news article here. The length of the news articles can be very interesting. We can obtain the length across various categories. From the plotted graph, we can see that the politics and technological articles tend to be longer, but not in a significant way. In addition, we will see in the next section that the length of the articles is taken into account and corrected by the method we use to create the features. So this should not matter too too much to us. The same graph, when enlarged, looks like this, where we mentioned that the political and technological articles tend to be longer. So we can see that the green and the purple boxes are higher in the graph. We can see that although the length distribution is different for every category, the difference is not too big. If we had two different lengths, that is, one having extremely high length or long art being a long article, and the other being an extremely short article, categorizing them would have been a problem since feature creation process may take into account counts of the words. However, when creating the features with TF-IDF scoring, we will normalize the features just to avoid this. At this point, we cannot do further exploratory data analysis, and we will turn on to feature engineering in the next section.